Let's talk about problem 6 of exam 2. In this problem, we are specifically asked to write the equation of the polynomial graph below. We're going to use a non-zero coordinate to find the vertical stretch factor, and a good hint is to make sure that you're testing your equation by checking a few points. So, looking at this right away, we need to identify what information we're given. Sorry for the poorly drawn graph. I did make sure each point is matched up to the original graph given on the exam. So looking at this, we're going to use the color red to decipher. We have a point at -2 right here. And the reason why this point is important is because it gives us information that we can extract from it. So at this, we see that the line, our graph starts here, and it works our way up to this -2, and it bounces, bouncing meaning it curves back towards the way it came, towards the -4. So we put a B right here for our information. At -4, as we can note that this is -4 because this is going to be our y-intercept and will be extremely helpful for when solving for A. But from this point, we got to look for our next x-intercept, and this is going to be at -1. Here, the difference between the 2 points of the first one and the second one is that we actually see a cross. So the cross will bump up all the way to our next point, and then you're going to see it come down to our next intercept at +3, and it's going to cross again. So we have a cross and a cross. That's the first bit of information that we can extract. Next bit of information can be the overall shape. So we can have two shapes when it comes to solving for a graph like this. We can have a quadratic shape, or a squared shape, where we have this parabola formed, and we can see the negative version of that as well, and this is produced by even exponents. So any even value. We can also, this will play into our zeros in our equation in general. So this is going to be an automatic 2. Our next shape is going to be our cubic, and we can also see the negative version. This would be a positive version, and our negative version as well. And this is going to be odd. And this is end behavior in general, and also our cross and bounce shape as well. So odd meaning 1, and if you actually see, this is called a horseshoe, this long expanded version, we can say that it's going to be 3 or above. Same shape, just a little more exaggerated on the horseshoe. You don't see any in this situation. Now, if we're going to set up our equation, we know that we are looking at our end behavior here and here, we're dealing with a negative even function. So with that information, we know that we're going to have a negative a value. And let's look at all our x points. These are also our x-intercepts and our zeros. So our first one is going to be -2, so we know it's going to flip. So we have -2, it would be x plus 2, and that ends in parentheses. We know it's a bounce, so this knows that it has to be even. So we're going to put a squared. Our next two terms come from crosses, which would be odd, and we have 1, again it flips, so we should have x minus 1, and this will be an odd function. And we are working with the even function overall, so we should have an even turnout. So the next and last point is going to be 3, so again it flips, x minus 3 raised to the 1, and all these will give us 4. So we are dealing with an even function, so that checks out. So that is going to be the base of our equation, but we have to find our a value. So a good way that we can find our a value is we go to our y-intercept and we plug in our values. So we're going to have -4 is equal to -a times 0 plus 2 squared, and x minus 1, 0 minus 1, because we're plugging in 0 for our x values, and 0 minus 3. Looking at this, now we can just evaluate. So we have negative 4 is equal to negative a. 2 squared 1, negative 1, and negative 3. Let's elaborate further. So 4 is a, this is 4 times a negative, which would be 3, which will have negative 4 times 12, and divide by 12, so we have negative 4 divided by 12 is equal to negative a, divide by negative, divide by negative. So we still have 4 12ths is equal to a. We can condense that to 1 over 3 is equal to a, and that term will still stay negative because we're dealing with a negative graph or negative version of an even graph. So our entire equation, which would be negative 1 over 3 times, make sure you include your f of x, is equal to negative 3 or negative 1 over 3 of x plus 2 squared times x minus 1 and x minus 3. And that will be our entire equation. Fix this before I go. Awesome. Again, a quick run through. We analyzed the graph, make sure to note where our y-intercept is, our bounce cross, remember our even and odd graphs, remember what we're looking for specifically, and then plug and chug. Thank you so much.